Can you see the slide?
Yes, it is clear, sir.
Yes, sir.
Yes, sir.
So for the textbook, you can use any of them. You can use the Hibbler or Peer-Johnston or Goodnow, but usually we refer to Hibbler. Okay, so please use this textbook. Okay, so this is the structure of the competency in the engineering mechanics. We have rigid body mechanics, deformable body mechanics, and fluid mechanics. Okay. So the strength of material, the mechanics of material is related with deformable body mechanics. So it is allow the deformation. So anything in the engineering mechanics which is allow the deformation analysis, then we call this the mechanics of materials, the strength of materials. It is different with the rigid body mechanics. In the rigid body mechanics, we consider that the body cannot deform, cannot change the shape, cannot change the geometry during loading. It will stay as it is. Even we apply very big load, we will not consider this body as a deformable body, so it will not change anything. We only interest with force, moment, and movement of the body, but not the change of the structure, not change in geometry of the structure. But for deformable body, if we apply the external loads, then this deformable body will change, will respond. It can increase the length or decrease the length. It can change the shape or not. Okay. So that's what we learned about the mechanics of material. Okay. So this is the course outline. First, we will learn about how the response of components if we give the axial load. What kind of stress that can be developed in that components and how it will deflect. Then next, we will continue if we change the load from axial into torsional. What change in stress and deflection? Can we use the same formula or not? Or we have to develop or use another formula. Okay. Then after axial, torsional, we change to bending load. And in the summary, we will apply all those types of loads. We call this combined loads. So what kind of stress will be developed inside the material if we apply all those types of load? Okay. So knowing the internal stress of material during loading allow us to evaluate the state of stress, just like I mentioned previously. Then this state of stress allow us to evaluate, to determine the maximum and minimum stress in the structure. Then we can describe, we can determine whether it is safe or fail. Okay, so I will skip this because it is speaking the same thing. Let's move to the first chapter. Okay, so I'm sorry that it's still in Bahasa, but let's discuss about this. Okay, we already learned about stress. Anyone can have definition about stress. Can you describe it to me? What is stress? Nadira, do you have opinions?
Maybe me, sir. Yeah.
Mhm.
So in my opinion, based on what I learned before, stress is some kind of quantity of physics that it express the internal forces
Mhm.
that exists between particles of continuous material that it exert on each other.
Mhm. So when you need to calculate the stress, what for? Why you calculate the stress?
Because the forces that is exerted on each other particles, so the stress is needed actually.
Okay, so any other explanation to add? We already hear what Nadira opinions about stress. So stress is quantity of physics, she said. Is there any other point of view? How about Raditya Rahman? What is stress?
Yes, sir.
Mhm.
About the stress, I think stress is a forces between the forces that work on some object with the area of the object, sir.
Okay, so we have load and we have area. And Raditya said, and also Nadira said that there is correlation between F and A. So if we apply F, external loadings on a surface on the area, then it will create the stress. Is that what you mean, Raditya?
Yes, sir.
Ah, okay, that's good. So you still remember this equation? Yes, of course. This equation gives us a brief picture about stress. Okay. So, is there any differences between the stress in material and the stress that happen to us? Is there any similarity for this? Here we apply external load. And here for the person, maybe he has many problems. Okay, so problem number one in the school, problem number two in the society, and any other problem.
Maybe I try to answer, sir.
Yes, Kazi.
For the object is maybe it's rather similar to the for someone like the biology or the physiology of the stress, but it's still similar, sir. So if that individual have something so much that is go to him or to somebody on, yeah, so the stress will come up. And also for the object, if the object has some quite not rigid material, and he lifting something that so big or so heavy, it's gonna make the object will maybe collapse or something like that.
Okay.
So it's basically similar, sir.
Okay.
But
so,
the implementation is different.
Okay. So here we can say that the stress is the intensity of load, right? Intensity of load, which measure the severity of the problems. Okay. So here, how to modify the stress? If the problem is the same, if the load is the same, we can increase the surface to minimize or to decrease the stress, right? Okay, because we cannot control the loading. For example, here we cannot control the problem. It can appear anytime, anywhere. So we cannot control P1, P2, and P3. So here what we can control is not P, but what we want to control is the surface. Okay, so the heart of these people or the surface of this material. If this person have strong heart, then when he receive many problems, it will not broken. But if his heart is small and weak, then after many problems he faced, it will be broken. So similar with this material. So the way to improve the strength of the material or the person is by changing the area, the geometry, or changing how we want to respond here. We cannot control the problem, we cannot control the load, but we can control our heart, our mind, and here we can control the strength of material, the type of material we can use, and the geometry of the material. So that's the similarity between the stress on the components and stress in our life. So the point is that stress is the intensity of load at a single area. Okay, the intensity. Okay, so let's continue. We still have 5 minutes for this introduction before the Zoom over. Okay, so let's take a look about the internal reaction. So we calculate stress is on the specific area. So for example, here we have a single body and we apply many type of loads on it. So where we calculate the stress, it depends on us. At which point we should evaluate the stress. So for example, if we want to evaluate the stress at this section, then we have to cut the specimen or the body at this section. After we cut this section, we can find that there are many internal forces working on that surface. And the direction can be any, can be upward, downward, and any direction. But even though we have many directions of internal load, we can always simplify those loads into the main components. That is the force and moment. So for this internal force, there are many forces acting at any point, but we can simplify this internal force into this resultant force and the resultant of moment, which is work at the centroid of the specimen. Okay. So in other words, we can say that if we apply these external loads on the body, then if we slice this body and evaluate the stress at this area, we can always find the resultant of internal force and the resultant of the moment in this area. How if we cut here at the different section area? The internal force, of course, also change. It is not the same as in the other cross section. So it depends on the location. So please be careful where we have to check the stress, because the magnitude and the direction can be different. Okay, so always evaluate the internal stress at the critical point. That's the idea. Okay, so having those resultant, force resultant and moment resultant, will allow us to decompose those resultant into components. So for example, here, after knowing the resultant of internal force and internal moment, we can dissolve or decompose the force into normal components and the shear components. We say this normal because it is perpendicular or normal to the surface area. So we call this normal force. And we have the term shear force here because the direction of loading is parallel with the surface. Okay, so now we already able to decompose this resultant force into normal and shear force. The same thing goes with the moment. We can also split up or decompose this moment in the normal direction and in the parallel direction. For the normal direction, we call this torsional moment that twists the material, twisting the material. And for bending moment, it bends the component. Okay, just like the beam, it bends the component. The torsional moment, for example, is for shaft, which is rotating. And bending moment is for beam, which is applied load, something like this. Okay, so the main idea is after we apply the external force, we can find the resultant force and resultant moment. Then we can decompose into shear and normal. We can decompose into torsional and bending moment. Okay, so that's the main idea. Okay, so see you again in the next 10 minutes. We will break about 10 minutes and see you again using the same link.
Sir,
Yes.
maybe I can make a premium Zoom premium for
but
next Zoom.